Today we'll be working with lesson 7.1, which is solving linear systems by graphing. In chapter 7, we talk about solving linear systems of equations. And what this means is we look at two lines on a graph. For example, here's your coordinate plane. And let's say you have one line that when we graph it looks like that, and a second line that when we graph it looks like that. What we're looking for today is the point where they cross, which would be about right there. And we'll be looking for an ordered pair, and that would be our answer. Linear systems that cross have a wide range of use in the business world, looking to see where two things are equal. We have three vocabulary words for this section. And the first one is systems of linear equations. That is, a system of linear equations consists of two or more linear equations in the same variables. So if we have x's and y's in one equation and we're trying to solve a system, the other equation needs to have x's and y's. Second, we have solution of a system of linear equations. The solution is an ordered pair that satisfies each equation in the system. And that's what we'll be looking for as our answer, is that ordered pair. And then a consistent independent system is a linear system that has exactly one solution. There will be other types of systems that never touch. If they're parallel, for example, they will have no solution. Or if you have two lines that are graphed the exact same, they would have infinitely many solutions because every point would touch. To solve a linear system using the graph and check method, we're going to do 3 steps. The first step is to graph both equations in the same coordinate plane. For ease of graphing, you may want to write each equation in slope-intercept form. Step 2 is, after you've graphed both lines in the same coordinate plane, you want to estimate what the coordinates are of the point of intersection. Step 3 is to check the coordinates algebraically by substituting into each equation the original linear system. In this section, we're going to graph them on our own, but in class we will talk about how we can use the graphing calculator to graph them, and then the calculator can help us find that exact point without having to do the estimation and then checking and guessing, because when we graph things, we don't always draw our lines perfect, especially in this note-taking guide that I'm doing for you right now. The lines may not be perfect because I don't have an option of a straight edge. So we'll talk during the next day before we do our assignment. We may take 2 days to do this assignment so that you understand how to use your calculator for that. Now we go on to example 1. We're going to use the graph and check method. Now before we get started, there's an error on this problem, and if we don't fix it now, we'll have an answer that's going to be very difficult to actually figure out. So I need you to change equation 2 to x minus y equals -1. Okay, that will save us some trouble in the future. So for our solution, we're going to go through the 3 steps that we just talked about. We're going to graph both equations. But for us to do that easily, we need to do what it says over here. To ease with graphing, write each equation in slope-intercept form. So let's take our first one. 3x plus y equals 9. and we're going to solve for y. This one's actually fairly easy to solve for y. We need to just subtract the 3x from both sides. Those 3x's are gone. You are left with y equals, I'm going to move my negative 3x to the front, make it negative 3x plus 9. And that way it's written in slope-intercept form. Now let's graph that. This means that it's going to cross the y-axis at 9, which is about right here. And it's going to have a slope of a negative 3, meaning we're going to go down 3, which will bring us down to 6, and right 1. Because negative 3 over 1, that's your slope, that's your rise, and your run. So remember, when it's a whole number, you always need to put it over a 1. That's going to put you at about right here. And it wouldn't hurt to go down 1 more. Go down 3 more and over 1. Connect those. Now on here, it's kind of difficult just because it's hard for me to get a straight line. Now we're going to change equation 2 into slope-intercept form. So we have x minus y equals a negative 1. I have to do a little bit more, one more step on this one. I need to subtract that x from both sides. Okay, so they're gone. But I still have a negative y, and again I'm going to put my x first, equals negative x minus 1. Now if you'll remember, and I'm going to move this to the left side here to have more room. If you remember, when you have a negative in front of a variable like that, and there's no other number, the easiest way to get rid of that negative sign is just to remember that every sign within that problem needs to change. So that's going to become a positive, that's going to become a positive, and that's going to become a positive. So you're left with y equals x plus 1. And let's graph that. That one's going to have a y-intercept of 1. So we're going to put the dot about right there. And a slope, that's a 1 in front of that x. So it's a 1 over 1, rise over run. So we're going to go up 1 over 1, up 1 over 1, up 1 over 1. When I drew my line, I didn't draw it very well. It actually looks like it crosses at 2, 3, just where I put that line twice. So we're estimating that it appears to intersect at 2, 3. But I need to check that out. So we will substitute a 2 for an x and a 3 for a y in each equation. So for the equation 1, it's going to be 3 times 2 plus 3. 3 times 2 is 6, and 6 plus 3 is 9, so that one does check. And in equation 2, we're going to substitute the 2 for the x and the 3 for the y. 2 minus 3 is negative 1, and so that does check. So because 2, 3 is a solution of each equation in the linear system, it is a solution of the linear system. Okay. And finally, there are 4 checkpoints. That would be a good time to pause your recording and then try each one out to see if you get it right. So for number 1, the first thing that you need to do is change each of those into slope-intercept form. So you have 2y plus 4x equals 12. Okay, I'm going to start off by subtracting 4x from both sides. 4x's are gone, so you have 2y equals negative 4x plus 12. I have to take this one step further than our examples did, and I have to divide by 2. Those 2's cancel out, and you're left with y equals negative 2x plus 6. Negative 4 divided by 2 is negative 2. 12 divided by 2 is 6. To graph that, you'll put your y-intercept is at 6, so right there. And it has a slope of negative 2, meaning you're going to go down 2, right 1. Down 2, right 1. connect those points, you use a straight edge. And the next equation is 2x minus y equals negative 10. You'll subtract 2x from each side. Those cancel out. You're left with negative y equals negative 2x minus 10. But like we did in that earlier example, change all of your signs. So you have y equals 2x plus 10. So it has a y-intercept of 10, which is about right there, and a slope of 2 over 1. So a rise of 2, run of 1. But if you notice, I can't go up and right without going off my graph. So I'm actually going to change those both to negatives so that I can go down and left. It does the same thing. So you go down 2, left 1. Down 2, left 1. And you connect them. They appear to cross right here, which would be a negative 1, 8. And that's your answer. You do want to check to make sure it works out if you're doing it by hand. Okay, now we'll move on to example, or number 2. I'm going to get rid of some of the writing here. Okay, for example, for number 2, we need to do the same thing first. We need to solve each equation for y. So I'm going to start with 4x plus 2y equals 6. I'm going to move this over a little bit so we have some more space to work. And I'm going to start by solving for the y. So I subtract 4x from both sides. The 4x's go away. You're left with 2y equals negative 4x plus 6. Again, I'm putting my x first. And then you'll divide both sides by 2. Okay, the 2's go away. And you're going to be left with y equals, this right here is going to leave you with a negative 2x. Negative 4 divided by 2 is negative 2 plus 3. Because 6 divided by 2 is 3. So it's going to cross the y-axis at 3 and have a slope of negative 2. So it's going to be negative 2 over 1. So we'll go down 2, right 1. Down 2, right 1. In our second equation, 3x minus 3y equals 9. I'm going to take 3x away from both sides. So that those go away. You're left with negative 3y equals negative 3x plus 9. And then divide both sides by negative 3. And the negative 3's cancel out, and you're left with y equals negative 3 divided by negative 3 is a positive 1. So it's going to give you a 1x, or just an x. And 9 divided by negative 3 is a negative 3. So this one's going to cross at negative 3 and have a slope of 1. So we're going to do 1 over 1 for a rise over a run. So we're going to go up 1 over 1, up 1 over 1. And when it looks like it's going to cross right there, which is the point 2, negative 1. And that is our answer. Need to get rid of some of that writing down here. Let's do example 3. And I'll move this one over here so I have some more room to work. The first one isn't going to be as bad to solve as some of the other ones. 2y equals 6x plus 8. I don't have anything to add or subtract from the left side, but I am going to divide by 2 on both sides. Those 2's cancel out. You're left with y equals 6 divided by 2 is 3. X plus 8 divided by 2 is 4. So that one is going to cross at 4 and have a slope of 3 over 1. Rise 3, so you're going to go up 3 over 1. Likewise, I can go down and left. So I go down 3 and left 1. Connect those. And then we do the second equation. 4x plus y equals negative 3. I'm going to subtract 4x from both sides. That's actually going to do that for me because I'm left with just a y equals a negative 4x minus 3. So it's going to cross at negative 3, but this one's going to have a slope of negative 4 over 1 or 4 over negative 1. We're going to want to do the 4 over negative 1 because I need to get up here. So I have to rise 4. So when I go up 4, left 1, it's actually going to put me where it appears to be crossing, is right there. But I can go up 4 again and left 1. And it looks as if it crosses at negative 1, 1. And that is my answer. And finally on to example 4 and our last one. The first one's already done for us. I don't need to change it, so I just need to graph it. It crosses the y-axis at 4. So here's my 4. And it has a slope of 4. So that's a 4 over 1. However, if I try to go up 4 and right 1, I'm going to be off the graph. So I'm going to make that down 4 and left 1. So to go down 4 and left 1 will put me there. Down another 4 and left 1 will put me there. I'll do my best to connect the dots. And for the second equation, 2y equals negative 3x minus 14. I'm going to divide both sides by a 2. It's going to leave me with a fraction on this first one, and that's fine. The 2's are gone. It's going to leave me with negative 3 halves x minus negative 14 divided by 2 is negative 7, so minus 7. So this one's going to cross at negative 7, but it's going to have a slope of negative 3 halves. Now if I try to go down 3 and right 2, I'm going to be off the graph again. So I need to change that to 3 over negative 2. Just by moving that negative sign to the bottom, it does the same thing. So I will go up 3, left 2. It looks like I find where it crosses. Up 3, left 2. And I connect them. It appears to cross here, which is negative 2, negative 4, and that is the answer. That is the end of the recording. You need to go back and review anything that may have caused you any trouble, and we will work on the assignment in class the next day. Thank you.